Hello student and welcome to our today's class. I want to welcome you to this particular class and specifically on this particular area that we are going to discuss today, which is on solving simultaneous equations. So in our previous discussion or the lesson that we had last, we talked about solving simultaneous equation using the elimination method. So we discussed about 3 examples, how we use the elimination method to solve simultaneous equations. Remember we said simultaneous equations are those equations with the two unknowns. So I want to use this one equation here so that we can actually have a recap of what we did. So you can have equations like x plus 15y is equals to 3 and 2x plus 3y is equals to 39. So in this case, we have got these two equations. So this is our equation number 1, and this is our equation number 2. So because we have got two unknowns in each equation, then we cannot use one equation to solve them, but we need two equations which now need to be solved simultaneously. So using elimination method requires that you eliminate one of the unknowns. You eliminate one of the unknowns. Here, it's supposed to be a negative here. So if you are to eliminate one of the unknowns, then it simply means that you make one of the unknowns to be 0. So in this case, you need to identify the unknown that you want to make it 0. But I said here, it is normally easier to eliminate the unknowns or the unknown that both of them are positive in the two equations. Like for example, you can note here we have positive x and here we have positive 2x. But here we have negative 15y and positive 3y. So it is easier to eliminate the x because they are actually both positive, but you need to make them to be of the same value. Whereby if here it is 2x, then this one need also to be 2x. To make that to happen, then you need to multiply the first equation by 2 so that both of them can be 2x, 2x, so that we can have 2x minus 15y actually is going to be multiplied by 2 so that we have minus that y is equals to 6. And then the second equation, we are not going to change it in any way because it is already 2x, so we just write it the way it is. 2x plus 3y is equals to 39. So one thing you realize now, because the two x's we have here, we can simply minus them to make them 0. So we can have this one to be 0. But here, remember, it is that negative 30 minus 3. So if you have a negative 30 minus 3, actually you are going to find if you are going to have negative 33. So this is the same as minus 33 is equals to, if you have this 6 minus 39, 6 minus 39, actually you are going to get it to be 6 minus 39 is going to be actually negative 33, negative 33. But note here there is a y. So we are going to have y is equals to negative 33 over negative 33, which is actually equal to positive 1. So that is very important. Upon getting one value or one unknown, then you can come and substitute in the other, where you have, like for example, the first equation was x minus 15y is equals to 3. But now you know we can substitute. We can substitute y with 1 because we know y is 1. Where we have y, we can simply put 1. So we can have x minus 15 times 1 is equals to 3. So x minus 15 is equals to 3. So x is equals to 3 plus 15. So x will actually be equal to 18. And at that point, we have solved for the two unknowns. So we know the value of y is 1, and we know the value of x is 18 using the elimination method. Then today, let us look at the method of substitution. From what we know, substitution involves replacing. If, for example, you are in a football match and you want to do a substitution, it simply means that you change or you replace the player who was in the field with the player who was outside. The same concept is applied here, where we normally substitute or replace a certain unknown with a certain value. This requires us to remember something we were taught in secondary, which involves making a letter to be the subject of the formula. So if I can use the same equations that we had, that is x minus 15y is equals to 3, and 2x plus 3y is equals to 39. And I'm now using the method of substitution. What I require here to do is to make one of the letters in one of the equation to be the subject of the formula. And you will realize that I can simply take negative 15y to the other side so that we remain with x on this side. Remember, to make a letter to be the subject of the formula, it simply means that that letter is left alone on one side of the equal sign and all the other elements are taken to the other side of the equal sign. So if we have x minus 15y is equals to 3, I can simply take negative 15y to the other side so that I remain with the x on this side, and at that point it will be said that x is the subject of this equation. So we are going to have x is equals to 3, negative 15y goes to the other side to be positive 15y. So at this point, because we have got x here and the others on this, then x is the subject of the formula or the subject of the equation. But this sign here is very critical. It simply means x is equal to this. So anywhere we have x in this second equation, we can replace with this. We can replace with this simply because they are equal. The sign tells us that x is equal to this. So where we have x, 3 plus 15y can replace it because of that fact that they are equal. So, and note here, if we have used the first equation to come up with an equation where an unknown is the subject of the equation, we cannot substitute in the same equation again. Now we need to substitute in the other equation. So in this case, equation 1 was used to come up with the x being the subject of the formula. Now we need to substitute x is equals to this on the second equation. So what we are going to have is actually this. It's going to be 2. Instead of x, we replace with this because x is equals to that. We replace with the 3 plus 15y plus 3y, what we had here, must give us 39. So that now here, if we open the bracket, we are going to have 6 plus 30y plus 3y is equals to 39. So that takes us to the point where we have, we can take 6 to the other side so that we remain with y's here. So we can have 30y plus 3y is equals to 39 minus 6, because 6 will go to the other side to be negative. If you add this, you are going to find actually you are having 33y is equals to 33. So y is equals to 33 over 33. I've just divided here by 33 and this side by 33. So y is actually equal to what? 1. After doing that, then you can be able to get the value of x. To get the value of x, go to the equation that you made x to be the subject of the formula. It is going to be easier that way. So we know x is given by 3 plus 15y from what we have here. But now we know y is equal to 1. So instead of having this y, we can replace it with 1. Therefore, x will be equal to 3 plus 15 times 1. Therefore, x will be equal to 3 plus 15. So x will be equal to 18. That is actually now the substitution method. The substitution method, first of all, make a letter to be the subject of the equation, and then you substitute, in the next equation. Where you have that value in the next equation, you substitute. And upon getting one value, you need to go back to the equation that you made an unknown to be the subject of the formula, so that you can replace it there for you to be able to get the value of the other unknown. That is basically what you need to understand in the substitution method. So I want you to try more equations that I'm going to provide, so that you can see if you are able to solve this. And I'm going to come back with more example as we move on. Thank you very much.